Hi everyone. So I just wanted to refresh my binary search logic, so that is why I did this. So okay, I just want to learn more about binary search. So let's see. So what does binary search mean? Binary search means suppose if this is the norms, and suppose if I want to find ascending order, write a function to search target in norms if target exists. So I just want to find a target. So I just want to find if 9 exists here in this one or not. Okay, so but here this is, since this is ascending order, one way would be to just search, and another way, instead of doing that, what we could do is, since this is an array which is monotonic or which is increasing. So to find a number, if a number exists or not, then I don't have to look at all the numbers. I can just look at the middle first. Look at the middle number and then see if it is greater than, or and see which side it might be on. If it is on the left side, then look at the left side and look at the middle again. So that way I could just cut our solution search space into half, right? I don't have to do that anymore. I don't have to uh, I don't have to look at all the elements anymore, because it is in ascending order. Yeah. So that way our search space, all, instead of linear, it would be, so it will always divide into half, right? We don't have to look. We don't have to look. It will always divide into half every time. So it means that it would be log of n solution. So log of n is equal to x. And what does x mean? N means 2 to the power x, right? Suppose x is equal to 2, then n will be equal to 4, or n will be equal to 8 if x is equal to 3, which means if there are 8 integers, 1 2 3 4 5 6 7 8, then our source space decreased to 3. X is 3, right? If n is 8, then x will be 3. So if in linear search it would be 8, because I would have to look at all 8 elements. But in binary search, I I would not do it. I would not have to do it 8 times. I would not have to search for 8 times. I can only search for 3 times. First search, and then second search, and then third search. So that is why it is log, because it cuts every time. It cuts by half, divide by 2, divide by 2, So that is why it is like, if n is equal to the power x, then x should be equal to log of n. So that is why log of n is the answer. Yeah. Yeah, so it means 8 divided by 2 is 4, and 4 divided by 2 is 1. Sorry, 4 divided by 2 is 2, and 2 divided by 2 is 1, right? So it is 3 times. Yeah, so this is opposite of 2 to the power, we are dividing every time instead of adding by 2, or instead of multiplying by 2. So yeah, instead of doubling the number again and again, instead of doing 2 into 2 into 2 into 2 into 2 into 2 like x times, we are doing here divide by 2, divide by 2, divide by 2, divide by 2, divide by 2 x times. So that is why it is that's what log means. Okay. So okay, now let's write the code then. So first of all, we'll divide the source space into half and see if that number is present there. If that number is not present there, then we will look into the other half, then otherwise on the other half. And if we reach to a state where we cannot divide any further, then it means that we have no, then it means that there is no any solution. Suppose in this number, if there was no 9, okay, if there was a 10, then first of all we have looked in the middle. Suppose this is 3, so 3 is less than 9, right? So we will look into this side, and then 10, so 10 is greater, right? So then we will look at this side, then 5. So since this is just one number, so there is nothing to look more, the source space has finished. So what I mean is, if it is I and j, and we look at the middle, so 0, 1, 2, 3, 4, 5. What is 5 divided by 2? 2.5. So let's say 2. So 0, 1, 2. So 3 is the middle now. And since middle is not equal, so we'll look at the left side. Oh, sorry. And since it is less, so we'll look at the right side. So now I and j starts from mid plus 1, and then j. Otherwise we would start from mid minus 1 and I. So now here also again the mid will be this one, and then this is also not equal, so this will be I, and then j will be this one. This will be I and this will be j. So if I and j are equal, or or if this something like this happens, then we should return. Okay, so since we can just write then. Sometimes like this can also happen. So this is I and this is j and this is m. So or suppose this is 3. This is I and j, and then if this is m, then suppose if it is on the left side, then suppose if this is if number is 0, okay, then it means that it should be on the left side of 1, right? So my I will be my j will be m minus 1 this j, and since it is in the left side, so only j will end. So in this case I became greater than j. So if I is equal to I less than or equal to j, then I should immediately return, because this initial pointer should never be, so yeah. Hey Siri. Hey Siri. If the mid is greater than the target, then the target must be on the left side, right? If it is less than the target, look at right. If norm's mid is less than target, then I need to look at the right side. Target must be on the right side. So if I want to look at the right side, then I must do I is equal to mid plus 1. J should be the same. But if I want to look on the right side, then on the left side, then j should be equal to mid minus 1. Wrong answer, really? Okay, it's accepted. But yeah, even if it is equal, sometimes it might be. Yeah, I should even still look if even if it is equal, right? Because yeah, right here this might be the case. I and j might be on the same number, and then that might be the source space. Yeah, I still have 5 minutes. In this case also it is the same thing, I think. Yeah, suppose if the target is 2, then if I did not find any numbers, so in this case where will ing end? That's what I'm thinking here. So ing will end in the last search space, right? If they will not find any search space. So first of all, ing, this is the search space, then 0 1 2 3 4 4 divided by 2 is 2. So 0 1 2, this will be the, this is greater, so we'll look at the search space now. And 2 divided by 2 is 1, so this will be the search space. This will be the mid, so this will be the search space. And okay, this will be the search space. And if it is not, the mobile is, so if I cannot find it here, then j and I will be here. So does this mean that search space will always go right, like left will always point at the number that is and target is 2 actually, and this is the search space, right? 1 only. So actually, since it should be on the right side, so if it is, if I want to search in the right side, then j will stay as it is. Actually only I will increase. This would be my I. Does this mean that the search position is the index of I? Very sleepy, so I'll just close my eyes and think. Okay, is it always the so my thing is, if the index where it should be inserted, is that index always where this left pointer ends? Is that always true? I'm sorry, my alarm is ringing and I will turn off, but it is too far, so, and I only have 21 seconds. Oh no, I'm thinking. What if the target was 0? So if this is a 1 and then this is I and j, okay, it ended and it ended here. What if the target was 0? If the target was 0, then it would have been the left, right? So at that case, I would have, my left pointer would have gone here. In this case also, it is like then that the thing that I said, it holds true. But how? Why does I have to move always? To right and to left also. If it is on the left side, then left side, then oh no, if it is on the left side, then actually if it is on the left side, then J moves in our normal condition. Yeah, they are also returning left always. But what if if there is just one number one, and I is also same, J is also same. Oh yeah, but that is true, right? I need to insert 0 here only. This is where I need to insert 0. 0 at, because it should be before 1. Yeah, that is true. So it will always be my left pointer, even if the number is less, even if the number is greater. Because even if the number is greater, I will always point to the number, that that greater number should be at. It should have been here. And if it is less, and if the number is not found, then I should be at that position only. Yeah, that is why. Okay, thank you so much. Bye. I know that I did not explain properly, but I'll try my best to explain it tomorrow. I will try to start very early, not this late. Okay, so that I will be able to explain more clearly. Yeah.